Hello? Oh, whoa. Can you hear me? Hey, you can hear me. Hey, welcome. How y'all doing? God, I am blinded. Good first day of the conference, yeah? Thank you. I'm Lynn Root. I'm your Lightning Talk chair. Harry is joining me. You want to wave? He's going to give you, he's much more funnier than I am, so if you come tomorrow, you'll be in for a treat. So we're going to dive right in. The first lightning talk of the day, Katie Cunningham telling me that I need a hobby.
You do.
Or you need a hobby, something like that. Welcome, Katie.
So, hi everyone, I am Katie Cunningham and I'm going to tell you why you need a hobby as soon as I get my mouse figured out. There we go. Okay, got it. So I talk to new devs quite a bit, and one of the pieces of advice I give them is to get a hobby. Because one of the things we do in tech is that we tend to, especially when we're just starting out, code all the time. We go to work, we code. We go home, we code on side projects. All of our socialization happens at conferences and meetups, and we just never get away from it, and we are consumed by it. And I tell them that they need to get a non-technical hobby. They need to get something that does not involve computers. So why? You know, if we love coding so much, we should love doing it all the time, and it should be our passion, man. Well, the first thing is you need to give your brain a break, because thinking in the same way all the time tends to be a great way to lead to burnout. It's a real threat when you let tech consume your life, and it has actually hit a lot of us that are now entering in our 30s and 40s, youngins, that I've watched many of my friends start to fall over from burnout because they spent their 20s just barreling through, and you don't want to do that. It also allows your brain to grow in different directions because all hobbies require research, they require thinking, they allow you to discover things that are different than what you would discover in your day-to-day job. It can also help your career, honestly. So one of my confessions, I, in my spare time, write this rompy fantasy fiction stuff. But that actually helps me hone my communication skills, because if I want to explain what the dragon looks like and how the orc died horribly, I have to do it clearly, and that also helps with documentation and writing emails to my CEO that are sternly worded. Also, so what if it doesn't help your career? You know, not everything has to help your career. Not everything needs to benefit your job, because companies can always get another developer, but you can't get another you. So you should take care of you. You also need more than one tribe. We tend to socialize within tech, so we only ever talk to other tech people, but knowing people who aren't technical is really a good thing. It gives you a completely different perspective. Also, eventually, all of us leave tech one way or another. Some of us change careers, some of us retire, and the sad truth is you will lose your friends when you leave, because we're going to keep on going to conferences and going to meetups, and it'll be less and less relevant to your life. So it's good to have another tribe to go to hang out with. So what should you do? What hobbies should you get? Well, I'm biased, but I like the fiber arts. I like making things. I knit, I sew, I embroider. You'll actually be able to buy some of these things at the auction, just a heads up. But I like doing this, and it's not technical. Writing and vlogging are also cheap, if not free, because you can find most of the software for absolute free, and it doesn't cost anything to put words on paper, except for maybe ink. Also, I've been told you can go outside and there are things to do there. I don't know. I'm allergic to the outside, so talk to people who have really nice hiking shoes around here, because the truth is the code will always be there on Monday, so you should go and do something else with your life on the weekend. Thank you.
Thank you, Katie. I specifically chose the Hilton so I could avoid the outside coming here. Hope that's okay. Next up, we have Łukasz Longa speaking about Black, the uncompromising code formatter.
Hello, everybody. PEP 8 is great. It's awesome. Among the many things it says a style guide is about consistency. Consistency with this style guide is important, but consistency with your project is even more important. Well, a foolish consistency is the hobgoblin of little minds, and PEP 8 itself has a lot of contradicting advice on how to wrap lines and how to format stuff and whatnot. So it's more of a framework for creating code styles than a single code style. Because a code style is an agreement between a group of people on a team. And one of Guido's key insights was that code is read much more often than written. So that includes code review. Code style should accelerate code review, not slow it down. It should decrease round trips between the author and the reviewer. It should remove noise so the reviewer can focus on whether there's bugs or missing things or whether we want the feature anyway. Diffs should be as small as possible so that the reviewer is not distracted by changes which have no semantic meaning. In this sense, a good enough formatting style is better than having lots of different formats. There's 4 fundamental components to our code style. Let's go through them now, and by doing so, introduce you to a subset of PEP 8 that a few people and I developed. We call it a black code style because it's any color you like as long as it's black. Yes. Horizontal white space. Well, when to put spaces, when to avoid them. Do what PEP 8 tells you. Easy. Vertical white space. What tokens always to break lines on, what tokens never to break lines on, and how many empty lines to use. Again, do what PEP 8 says. But when you have bracket pairs, always put an empty line after the last element and dedent it. That's awesome because you already do this for dictionaries, lists, and whatnot. Now you can also do this for if statements and function signatures and whatever. That way, you delimit the function signature from the body, the if test from the body of the if statement. That's uniform. That's great. Line length. Ha, cool. Which one should we choose? 80 or 120? Neither. If you read Raymond's Hettinger Beyond PEP 8 talk, he talks about 90-ish. Raymond Hettinger is one of the most experienced Python developers out there. He's a code developer for over a decade. He's a teacher, and he, as a consultant, seen tens of millions lines of Python code. So when he says 90-ish, I believe him. I have no reason not to. Like if you create a class, in that class you have a method. In that method you have a context manager, and then you have an if statement. You already lost 4 levels of indentation. So 80 or 79, as PEP 8 actually says, is a little too little. Consistency. It's nice if we're consistent. If we, for example, use trailing commas everywhere, unless it fits in one line, then we remove unnecessary trailing commas. We also standardize on double quotes, because now you'll never know if this is an empty string or a single double quote. So we standardize on double quotes, we standardize on lower level strings. Cool. It anticipates apostrophes. You're going to use them, so why not, start with that? You're writing docstrings, right? So PEP 257 actually tells you to use double strings. So again, double strings. We interact a lot with C because it's Python. Again, double strings. So this is what you should be using. So that's sort of the gist of the black coding style. How do you enforce it? You install a tool, because it's also an auto formatter, and then you can forget about it, right? It is not really configurable. It requires Python 3.6, but you can still format Python 2 code with it. It reformats entire files in place. It already has a lot of integrations with editors, so if you use any editor, you are probably fine. So what's the status of the tool? Let me share my roadmap with you. No, not this one, sorry. So the actual roadmap is this. Alpha, beta, stable, and we are somewhere here. I actually plan to release the beta at the sprints. What that means is that we are going to have a stable formatting. I'm not going to change how I format stuff under you anymore. I will likely have bugs, but that's it. The project is already pretty popular. Please help me get to 2,000 stars at this conference. I think we can do it together. Why not? It's actually already also released where I work. And at Facebook, it's seen very good feedback. Well, not exactly uniform, but try it out. Then you can actually decide whether you're this one guy or all the other people. So my name is Łukasz Langa. I wrote black. Please use it. Thank you very much.
All right. Thank you so much. Next up, we have Sage Sharp speaking about Outreachy.
Hello. So I'm talking about Outreachy, which is an internship program. It's a 3-month internship program, and it's completely remote. Anyone from around the world who meets our eligibility criteria can participate. And you get a $5,500 stipend. And also, interns who participate in Outreachy get a $500 travel stipend to go to a conference or event that is relevant to their project, like PyCon, for instance. Outreachy is open internationally to women, both cis and trans men and genderqueer folks. And in the US, it's also open to people of any gender who are Black, African American, Hispanic, Latino, American Indian, Alaska Native, Native Hawaiian, or Pacific Islander. And the goal of Outreachy is to connect these people with open source projects. We run twice a year. There's a 6-week application period where the applicants come and they make contributions to projects that are listed on the Outreachy website. So they may have a bug or a documentation change in your project, and they may actually try to contribute that upstream. So you, as a mentor, get to see how these applicants work in your project, and the applicants get to see, is this project interesting? Do I have the skills for it? Do I like the mentor? It's a 3-month internship, and you can apply in February and March for the May to August internship, or September to October for the December to March internship. How it works for applicants is they fill out an eligibility form to make sure they fit our application criteria. And our website is actually built in Django. So if you're interested in helping us out, I will be sprinting on Monday on the Outreachy Django website. So applicants find a project, they contact the mentors, and they ask a lot of questions. Be prepared for a lot of questions. The best applicants make multiple contributions to the project during the 6-week application period, and then afterwards they fill out an application form to say, yes, I'm still interested in the internship. So last round we had 200 people make a contribution to an open source project, and 70% of them had at least 2 contributions that they made to a project. And we selected 44 interns for the last round. There's all sorts of Outreachy projects that participate, definitely Python projects, Django projects, and a lot of other different kinds of projects that participate. So how can a project get involved in Outreachy? So you need a coordinator and at least one mentor. Sometimes they're the same person, but oftentimes it's better if they're separate. We do encourage co-mentorship. Also, the projects that participate need to provide funding for one intern, but Outreachy does have general funds that we get from companies that sponsor Outreachy, and so we can sometimes give projects an additional intern if they have a lot of really good applicants. If you're going to get involved in Outreachy as a mentor, you need to have a project that the intern can work on. So the mentor proposes the project. And during the 6-week application period, there's a lot of applicants that come in. And this is really a test of your community. Is our documentation good? Do we have enough newcomer-friendly issues so that these applicants can have enough work? Do we have people who can answer questions on our community forums? So it's a really good way of seeing firsthand whether your project is newcomer-friendly. So if you're interested in Outreachy, you can check us out. Check out the website. There's also a link to the website's GitHub repo if you would like to help us out with some Django work. There's lots of open issues. If you're interested in Outreachy tonight, I'm in the open space at 7 p.m. on Friday in room 14. And you can also find us on Twitter. Thank you.
Thank you. All right, next up, we have Josh Lowe talking about Edgy blocks.
Hello, my name is Josh, and today I'm going to introduce you to a project that I created when I was 12 called Edgy blocks. I'm a 14-year-old software developer. So what is Edgy blocks? Edgy blocks is a drag and drop version of Python 3. EdgeBlocks allows you to build basic and complex Python 3 programs using a Scratch-like interface, and it is being used in schools in 72 countries across the world. EdgeBlocks is an easy way to learn the Python 3 syntax. EdgeBlocks has the Python 3 code on the blocks, which allows you to see what you're building in Python whilst allowing you to use an easy-to-use interface to build Python programs. EdgeBlocks is an educational tool to help younger children learn Python. EdgeBlocks has been proved to help lots of people get into Python, allowing a small barrier to entry system to build Python programs. EdgeBlocks is also a platform for educators, so we provide a lot of resources and lesson plans free to use on the website to get started straight away. So what is the need for EdgeBlocks? In schools, Scratch is being introduced at an early age, and then Python is introduced. Scratch to Python is a huge gap, so EdgeBlocks is the solution to bridge the gap between the two. Introducing EdgeBlocks. EdgeBlocks is still the same Scratch-like interface which has the blocks, but instead allows you to see the Python code, allowing you to make the transition easier. Here is a quick demo of EdgeBlocks. So you drag and drop the blocks from the toolbox on the left. This is the Raspberry Pi version, and you can see that you're building up a Python program. You drag and drop the blocks, connect them together to build up the program on the screen. Here is a simple print statement inside a while true loop, which will then run in Python. We will now switch to Python view, which brings up a text editor, which allows you to further develop the Python code. You can then run it by the click of a button, and there is your Python code running. EdgeBlocks runs on two major platforms, the Raspberry Pi and the Microbit. The two links are below if you'd like to visit those additions. In the future, I'm also introducing Adafruit CircuitPython, which you all got in your swag bags, the Gemma M0, which also works with EdgeBlocks in the future. EdgeBlocks is a free-to-use program, but unfortunately it's not free to run because I have to buy the boards to test it. So a Patreon page is there if you'd like to support me with EdgeBlocks. Thank you, and thank you to the community for allowing me to speak. You can find out more on the links on the slide. Thank you.
That was awesome. Thank you. All right, next up we have Mahmoud Hashemi on restructuring data in Python.
Good evening, Cleveland! We're excited for some Python, I see. They say you should start a presentation with a quote, so I've got one here for you. It's one I think you've all heard before. Flat is better than nested, by Tim Peters, PEP 20, a little while ago, otherwise known as the Zen of Python. So with that Zen movement, we move into a new quote. Namespaces are one honking great idea. Let's do more of those. That's also Tim Peters, PEP 20, the Zen of Python. So, these two statements in tension are a lot to meditate on. And I think that meditation may have been lost or maybe just not available to all the Java developers in the world because we end up with data that looks like this. And note the ellipses. This goes far off the page. So, and it gets a lot worse when you get into enterprise environments and aren't just dealing with web services. So, what do we do about this reality? Glom. It's a tool that is the nested data operator for Python. No longer is flat strictly better than nested. It's a choice that you can make. Truly Zen. All right, you can find it now. It's on GitHub. Please have a look. But let me talk to you about what it actually does. So first up, I think this is maybe the most common case, and the first few times I wrote something like this, this is what it did. Basically, it gave you a dotted syntax for reaching into dictionaries. Basically here we have a target, galaxy, system, planet, Jupiter. Not a great structure for the data, but with Glom, it's no problem, right? You can just move straight ahead. But it goes, but see, here's the whole reason you need that in the first place. If you have a line like this, right, basically you could get 4 different exceptions Now, experienced developers are going to actually split this up into a bunch of different try-except blocks, but it still gets to be pretty tedious. For these last two exceptions, none type object has no attribute get item, and list indices must be integers. I encourage you to figure out which of the data structures actually had this problem, the one where I'm accessing B or the one where I'm accessing C. What we need is we need good error messages, right? It's more than just a dotted syntax for reducing lines of code. It actually gives you an error message that says path access error, could not access C in index 2 of path ABC, got error. You know, it gives you the underlying error, and you're definitely no worse off than when you started, and in fact much better. But it goes much further than just access, right? Because what I realized over the years is that I don't just need to access one field, I need to access a whole series of them to build a new object. And what I get there is basically I should be able to accept more than just strings as input. Instead, in this case, we've extended the data structure to add Earth with our 1 moon and Jupiter with its 69 moons. And you know, I want a list of names and a list of moon counts. And with Glom, you can do that. You just say, give me a data structure that looks like this. So it's related to the list comprehension. I love list comprehensions because the data that you get out looks like the code itself. And in this case, it's similar. You declare a structure, hand it the target, and it renders something like this. And so for this kind of system, we've just sort of ended up calling it like an object template. You know how when you're making an HTML template, like with Django or something like that, you basically say, oh yeah, take this value and put it in this div, and take this value and make an unordered list from it. Here, it's very similar, except you're saying, take this object and please make it into a dictionary. Take this object and please make it into a list, so on and so forth. So, to review, we have path-based access, declarative data transformation, and readable, meaningful error messages. And to go a little further, features I don't have time for, it has built-in data exploration and debugging tools. So right now, I have Glom specs, as I call them, that are dozens of lines long, replacing code that's hundreds of lines long. And, but at the same time, it can be kind of complicated to debug. So it actually has a built-in debugger thing. And it even has a command line tool. It's like JQ, but there's no DSL. You just write Python. So, yes, with that, I would encourage you to pip install Glom today. And if you want to know more, I've written a blog post about it. It's at that URL, sedimental.org. And also, there's an open session tomorrow at 4 p.m. Hope to see you in room 10. Thank you very much.
Thank you. All right, next up we have Quang Vu talking about Python code style for blind programmers. I might be blind.
Hi, everyone. So I'm going to talk about code style for blind programmers. So why is it a challenge? Because Python is an indentation-based language. So that's the number one reason it's very difficult for blind programmers. The way they code in the way blind programmers code, they have the screen readers that read all of the character on the screen for them. So this Python determines the scope by using space. So that is very challenging for them. And I hope that by the end of the talk, we can do something better to help them. Because Python is very popular right now. And not being able to code in Python is a big barrier for blind programmer to keep up with us. So let's start it. Indentation. Raise your hand if you use space. Raise your hand if you use tab. So about 95 people here using space, and about few people using tab. So if you use for blind programmers, the screen reader going to read the first line is def foo, and then the second line going to space with open text, and the third line it's going to read space. It depends on a different configuration, but some different configuration it's gonna read the second line at space 4, the third line space 8, so it's easier for them to keep track of what the level indentation. So how type of space help? Oh, by the way, don't do the comment on the sides, because imagine like you're gonna read all the space in between, so that's gonna drive them crazy. So do comment on top of your code. It make it easier for them to read. I should do it for my demonstration purpose. So This example copies straight from PEP 8. So it's valid for most of us. But imagine if for the screen readers, this is 10 space. So it's non-usual. So if they configure their screen reader to be 4 space, 8 space, and they come across like 10 space, it's pretty confusing. And also what it means we have type is like 2.5 type space. So yeah, if the best way for this is avoid doing lineup, you should just do this instead. So line everything on the level indentation, make it consistent throughout your code. Long string. So we all know about an 80 character limit, and I believe some developer right before me he talked about that too. So that's very many people have different opinion on that. But if you for blind programmers, they actually have no meaning for them. So it better if you concatenate all the string together. Don't split the string. Even though it look better, it keeps your linting quiet. But for them, it have no meaning. So if keep all the string together, easier to read, easier to understand too. Line separation, actually it is too long, so I have to pull up the real code. So this is one of the real code, and you can see in here, really long function and no separation. What I mean by separation is that usually if you have a code block, you separate by a blank line, but for blind programmers, they have no meaning. So separate your code by blank line, it just create more noise. So they have to skip that when they read the code. So yeah, be very considerate when you use your blank line to separate your code. That's my favorite, because if some of the people who work with me before, they will recognize us, because I'm a fan of putting diagram into my docstring. Easier for me to read, easier for people to follow, but not so much for applied programmers, because like they read this code, they can't make sense out of it. They don't know what it is about. So try to put word into your docstring. Don't try to use a diagram. So what we can do to help them? First of all, reach out to them. Be open-minded. You read code and you see something weird. So why does that guy keep 200 line 200 character longs? It maybe there are a reason for it. And be helpful to them. Reach out to them. I do my research only for 2 people. So the number of people I know is very limited. So if you know more people, reach out to them, help them, do what you can. And also, this is a program I was talking about. It's called NVDA. It's a non-visual desktop access. So it was written entirely on Python. So the problem with that is that it only works for Windows. So Linux, Mac, they pretty much have no choice. So we are Python developers. If we can help them reach that'd be really helpful for the communities. And if you have any suggestion, if you don't agree with what I'm suggesting, send me an email and let's discuss and then make it happen. Thanks. Thank you.
Thank you. Next up, we have Alex Rosengarten on Music from Chaos.
Thank you. My name is Alex. This is my first PyCon. I'm excited to be here. I'm presenting Music from Chaos, audioifying the Loren detractor. So I'm using a small computer music library that I wrote with a friend called Computer Music. And we're answering the question, is Python an instrument? I say yes. You can find the GitHub link here. I'll show it after the talk. So I'm going to talk about oscillators, a voltage control oscillator, and then the Loren detractor. So first, what is an oscillator? An oscillator is, in some sense, the atomic unit of an audio file or sound. You can visualize them and see that they're a pretty intuitive concept. You have, for instance, like 3 basic oscillators. You have a sine wave, a square wave, and a triangle wave. And they sound something like this. Just a pure tone, a bit rougher, somewhere in between. Now, an oscillator on its own is not super useful for making meaningful music. We would like some way to control the frequency over time, and thus we are brought to the voltage-controlled oscillator. So just to get an intuition about how these work, more or less, we have a control signal, T. In this case, it's just x equals x, or at each time step, plot the time step. And you can see that when you apply a voltage-controlled oscillator to it, it increases linearly. So the frequency gets increases proportional to the control signal. And you can do all sorts of interesting control signals. Maybe a basic case, if you have a flat, if you have a flat control signal, you'll have a wave that is completely consistent. And if you have fancier control signals, like a parabola, you can get a more interesting output wave. Now, given all of this, we can use, one last thing. Now, even with a voltage control, it's still not, we don't have all the tools we need in order to make meaningful music. We would like some way to digitize or make distinct notes. So we offer a few more functions. So we have a raw control signal. Here's the sine. We discretize or digitize the signal into distinct steps. We map those discretized signals into frequency, like meaningful frequencies on a musical scale, for instance, like the chromatic scale. And then we apply a voltage-controlled oscillator to it, and we get an audio output. So here's what this sounds like, more or less. Kind of repetitive, but getting more interesting. Now, what if we took something that was chaotic, or used a more complicated control signal in order to power our music? And now we enter the Lorenz system. So Lorenz is a nonlinear set of ordinary differential equations that's used to measure convection in fluid systems. And it has this kind of a shape. If you plotted the x, y, and z axes, it would look something like this. Now, we could listen to this directly, because they are values between -1 and 1, but if we use voltage control signals, we can get more interesting, more meaningful music. So now, with my remaining time, I'd like to show music composed by my friend Jason Dorr. I'll have you note that because this is a chaotic signal, it's very sensitive to the initial conditions. So here we have initial conditions 2, 3, and 4. It is done rendering. And this is what chaos sounds like. Oh, I'll keep that playing. So I mentioned the initial conditions, and what does chaos really mean at the end of the day? So here I'm running this one more time with the initial conditions that are slightly perturbed or slightly off. And what that means is that as time goes on, if you were to start playing these at the same time, they start out very similar, but then get, slowly, they get more and more different and start generating entirely different audio files or music as a result. So that's audioifying chaos, or the Lorenz system. Thank you.
Thank you. Thank you very much. That was awesome. All right, next up we have Shauna Gordon-McKeon on Legacies of Disruption.
Hello. On August 6, 1945, the White House put out a press release lauding the greatest achievement of organized science in history. That achievement was the atomic bomb, which that morning had been dropped in Hiroshima, Japan. Between 60 and 70,000 people were killed immediately, with tens of thousands more later succumbing to injuries and radiation sickness. We can debate what it means for an achievement to be great. Surely many scientists would prefer to think of the discovery of penicillin or of the moon landing as the best part of their legacy. But in one way, the White House was clearly correct. The atom bomb was the most significant political achievement of organized science, and the achievement which had the biggest impact on world politics. Many scientists prefer not to think about politics, but the work that scientists do has always had political consequences, and it's the same for technology. We like to think of our work as apolitical, even as the counterexamples pile up. Corporations and governments surveilling citizens, black box algorithms that tell us what news to read and what people to trust, world leaders threatening nuclear war on Twitter. We can learn from the nuclear physicists of the early 20th century. Their discoveries were truly disruptive. They moved fast, and they nearly broke the world. Back in September of 1933, less than 12 years before the first atom bomb was dropped, Ernst Rutherford, often called the father of nuclear physics, labeled the prospect of nuclear weapons moonshine. He was hardly alone in his opinion. Albert Einstein had described the pursuit of nuclear fission as shooting birds in the dark in a country where there are few birds. And Niels Bohr, another luminary, repeatedly dismissed the possibility. These people had seen and led multiple scientific revolutions. Why were they then so sure that another revolution couldn't happen? Perhaps they didn't want to believe. I loved science, said Edward Teller, a Manhattan Project scientist, but also it offered a possibility for escaping this doomed society. Theodor von Karman agreed. I felt I had had enough of political and government upheavals, he wrote. I was enveloped in the feeling that only science is lasting. Lise Meitner, known as the mother of the bomb, wrote that back then, one could love one's work and not always be tormented by the fear of the ghastly and malevolent things that people might do with beautiful scientific findings. Once it became clear to scientists that atom bombs were in fact possible, many of them clung to the belief that these bombs would somehow save the world. Eugene Wigner, who helped launch the Manhattan Project, believed that nuclear weapons would require a world government to control them. He wrote, "We expected that these controls, if they were effective enough to abolish atomic warfare, would be effective enough to abolish all other forms of war." The same hope was shared by Carl Friedrich von Weizsäcker, who worked on the Nazis' nuclear program. He wrote, "Mankind itself can only survive if war as an institution is abolished." In their words, we can hear the echo of Alfred Nobel, the man who created the Nobel Prize and the weapon dynamite. He said, "Perhaps my factories will put an end to war sooner than your Congresses. On the day that two army corps can mutually annihilate each other in a second, all civilized nations will surely recoil with horror and disband their troops." There's a kind of magical thinking in the words of these men, that a new technology could, just by existing and with no thought for politics, bring about world peace. The fact that the technology in question was a devastating weapon only adds to the irony. In just 12 years, the atom bomb transformed from moonshine to reality, changing our world along with it. Most nuclear physicists dismissed the feasibility of the bomb even into the late 1930s. While individual scientists will always get things wrong, the field's collective failure to identify the bomb as a dangerous, if unlikely, outcome and to address it set the stage for the destruction of Hiroshima and Nagasaki, for the Cold War, and it threatens us still today. The tech industry may face a similar reckoning. What dangers are we ignoring today? What dystopian futures and Black Mirror episodes are we dismissing as impossible? What tools do we still blindly insist are going to save the world when they might destroy it? Even more importantly, how do we face up to these dangers? How do we hold our communities, our companies, our industry accountable? What kind of collective organizations should we build? What kind of collective actions should we take? What is our legacy going to be?
Thank you. All right, next up, Travis Oliphant, speaking on more sustainable open source.
Excellent, thank you, Lynn, and thank you for that talk. I say make more open source, not war. It's actually been true as I've gone around the world, amazing the amount of the impact that open source can have on bringing people together from all walks of life. You might know me from some of the open source I've contributed in the past. I've made a career out of working on open source from NumPy down to Conda and Numba, working with the NumFocus organization, and then promoting other projects like Dask, Bokeh, and then the PyData ecosystem. Come sprint with me. We're doing something again, XNDIO. We're going to sprint here at PyCon. It's array libraries, primitive libraries for array computing. If you want to get into it, we're going to get into it. So come, it'll be fun during the sprints. Sustainable open source is very personal for me. I've been doing this for 20 years, and I had little kids when I started, and I wondered how in the world I'm going to pay for their college working on open source, giving my software away when I started giving away SciPy as a grad student. They're now older and they're in college, and I'm still trying to figure that out. But it's something I care deeply about. So I've worked in industry and I've led companies, I've started companies to try to help people get paid well working in open source. Doing it again with Quansight. We've come up with an approach to hire people, to work, mentor people, grow them in their careers, connect them to companies. We actually have this concept called sustainable open source that connects open source communities with companies that need them. We provide the companies with prioritization on their features, with the ability to hire from the open source communities, as well as mitigating their open source risk. And to the communities, we offer the ability to connect their roadmaps and collect their ideas and present them in fundable nuggets so that companies can absorb them well. So we call that our sustainable open source subscription. We were doing that at Anaconda, Continuum as it became Anaconda. We were doing this and grew a 35, 40 person team. It's the foundation of Anaconda's open source actions today. That can grow, that can broaden. That's why I spun out of Anaconda to grow it even farther. So we're organizing roadmaps, we're organizing community ideas, presenting them to companies, but we need help. We need people. We need lots of people. We need community-minded people, developers, evangelists, community managers, project managers, and we need them part-time, full-time, freelancers. So introducing Open Team. Go to the website, openteam.quansight.com. You can go there, sign up, basically show you're available. It's not much now. Right now, it's basically a chance to raise your hand and say, hey, I'm available for this amount of time. I need to be paid this much. And it's a way to connect. Eventually, we're looking for occasional part-time freelancers. If you want to come work full-time for Quansight, that'd be great. You got to be passionate about open source. In the near future, find collaborators, advisors, people to help you connect to open source projects. Outreachy is interesting. I'm probably going to follow up with them. So come join us. The website is openteam.com, openteam.quansight.com. It's got this subtitle there. You can just go in and log in with your GitHub and become a part of it. Become a part of the next adventure. Thanks, everybody.
Thank you, Travis. All right, next up we have James Powell, Code or Die.
So this is Code or Die. It's a lightning talk. Hi everyone, I'm James. Hi, how are you doing? You can follow me on Twitter. Don't use this code on Twitter. I wanted to show you something kind of different. Usually for lightning talks, I show you something kind of wild. This is actually an idea that I like, and I think it's actually a good idea. And it's unfortunately an idea where I can't really find the time to do it. I can't find the resources. And what I'm trying to get out of this talk is an opportunity for me to motivate you, to actually motivate me to actually finish this thing. So let me show you the idea. And if you like it, maybe on Monday we can sprint on it. You tell me what you think. So a lot of you have played board games. A lot of you are familiar with one of the classic board games, Risk. So let's imagine Risk. It's a board game. We've all played it. It looks kind of like this. Let's take it. Let's set it in space. Let's add spaceships and solar systems and all the accoutrement that you'd expect. Let's make it real time. Let's take away the board, because we don't need a board. And instead of a board, we'll put in a JSON API. And when I teach you to play this game, if you're a first-time player, I'll give you a handout. And on that handout, I'll say there exists this tool called HTTPy. There's also a tool called curl. But here's just a couple of things to just type into your console. Type in this. Oh, you get to see what solar systems are out there. Type in this. You get to see what are the ships where I am currently. You type in this. Oh, what's going on in solar system number 32? You type in that. You say, oh, look, I'm moving my ship to some particular position. And you can see it's a very simple, very low-level API. The actual amount of work to put this together is intentionally minimal. Now, when I give you something like this, as a programmer, what's your first intention? Well, this is ship 12 moving to Mars. What if I make that ship 23? And what if instead of Mars, I move it to Venus? And without teaching you anything about the game, you're already trying to figure out certain aspects of how the game works, how the pieces move. It's pretty easy to play. Now, in the first 30 minutes, I can teach you how to play, how to move the ships around, how to shoot other ships, how to take over solar systems, with just like a handout of some simple API calls. But what if you have to move 100 ships around? Round 2, let's up the ante. And maybe what you need to do is you'd write a bash script. You'd come to me and you'd say, I need to move 100 ships. I can't type 100 commands in real time, so I'll write a simple bash script. I'll move them all at once. But the API output from this is in JSON. It's going to be really hard to read. It's going to look something like this. And so you're going to say, you know what? I'm going to write a little reporting tool. Or maybe I'll write a web front end. And if I have hundreds of ships moving in real time, interacting in real time, even if I have scripting to help me out, I can't actually win the game. So I might need to write bots. I might need to use some ML or AI mechanisms. And what you can see is, the thing I like about this game is it starts very simple and it gets very complex. Even newbies can play. And it's a motivation to learn programming. It's a motivation to improve your programming. And what I like about it is, through this automation approach to programming, you have a very immediate motivation. When I do corporate training and people ask, what's the business use case for a meta class or a decorator? I don't have an answer for them, but if you come to me and say, look, I wrote this code, I'm losing every game I play against my friend, and I say, well, you know what? Maybe you need to try a new approach. Maybe you need to use Flask instead of something else. Maybe you need to use a pull API instead of a push API. The motivation becomes very clear and very immediate. And one thing I really like about this idea is, as you're learning to improve your code, as you're learning to figure out what it takes for you to beat your friends, you realize perfect code doesn't really matter. Code quality isn't the most important thing. What's important is only one thing: galactic domination. So if you like the idea, it's on GitHub. The rule sits on GitHub. I've started working on this. Come find me on Monday. Maybe we can sprint on this. Maybe we can finish it. I don't think there's a lot of work to finish it. Maybe we can start, at a point where we have some games running and we can see if this idea works or not. Thank you so much.
All right, we're gonna figure out some display stuff over here. Who's going to the PyLadies auction tomorrow? Anyone? Well, if you don't know about it, it's happening tomorrow at like 6:30, or it starts around 6:30, but doesn't actually start until I get there, so maybe like 6:45 or 7. And if you haven't registered for it yet, you can register at the door. And all the money that we raise will go to women who needs to attend PyCon, their registration or hotel or something like that. So yeah, you should all come. And if you don't want to bid, maybe bid up people to help raise more money, because that would be awesome. Maybe Harry can help me tell some jokes, because I'm horrible at jokes. What? Oh, raffle tickets, yeah. At the auction, we have some raffle tickets, too. I have no idea what the prizes are, but there will be raffle tickets. Sorry, Katie. Harry, you wanna vamp with me? He's much better at jokes.
Hi, everyone. How much time do we actually have to waste, Lynn? Because I've got a joke that takes about 3 days. Yeah, we could have somebody up next instead of Caleb. Who was after Caleb? Is it Sean, Scott? There you go. You can go and get set up here and we'll have another go. Fine. My favorite joke I heard recently was from a Polish programmer, and she said, this is my grandma's favorite joke, and it's about a programmer's walking down the road, and she finds a horseshoe on the floor, and she picks it up, she looks at it, she turns it over, and on the other side, there's a horse. It's a bit of a wacky one, that one. Did I hear the one about the broken pencil? Don't worry, it's pointless. Wait, no, that's enough, James, come on. A pirate programmer walks into a bar, and he's got a parrot on his shoulder, and it's going, pieces of 7, pieces of 7, pieces of 7. And the barman goes, I think there's something wrong with your bird, mate. And he goes, yeah, he's got a parity error. And the barman goes, yeah, I thought he was a bit off. It's double, it's got a topper, that one. Yeah, are you ready to go? Okay, carry on.
Thank you.
He's so much better at that than me. All right, thank you. We have Scott Shawcroft on CircuitPython, code and community.
Thank you. Hello, everybody, both PyCon people and internet people. I'm Scott Shawcroft. I'm a freelance developer for Adafruit on CircuitPython. I'm going to show you a live demo. So hopefully it works. It worked yesterday. So what I have here is a Adafruit Gemma M0. It's a tiny board. It's what you see there. And what I'm going to do is I'm just going to plug it in. It's got CircuitPython on it. For those of you lucky enough to be here, they're in your swag bags, so you can try this. And what it should be doing is it should be doing a rainbow color shift. But it's quite dim because we don't want to blind people when they plug it in. And so my goal here is to turn the brightness up. So While I plugged it in, it showed up as a USB drive here. This is the code part of CircuitPython. And what I got was a listing of all the files on the drive. And on there is a main.py file, which I'm going to open in Atom. And it has big text, so you should be able to read it. And the one thing I wanted to do was set the brightness to 1. Oh, don't want to do that. So I'll set it to 1, and then I'll go File, Save. And it should be brighter. I can't actually see it, so hopefully it worked. Thank you. So I wanted to show you how easy it is to get started using CircuitPython. I could do it in a lightning talk. You can do it in the next 3 minutes if you like. That's the code part. This is how easy it is to get people using Python on hardware, which is super cool. Now I want to talk a little bit about the community. We have a Discord channel, which is a freely available chat service. We have a code of conduct, and we will ban people if they violate it. So we keep it a very open space. In addition to that, we have the Adafruit learning system, which is a bunch of tutorials on what you can do with CircuitPython and different pieces of hardware. We have all of our code is open source. It's based on MicroPython. You may have heard of it. They've done a great job, and we made it better for beginners. So check out our GitHub. And we're also on Read the Docs. If you're here at the conference, we're having an open space tomorrow and an open space on Sunday as well at 2 p.m. in room 20. So come visit us there. And if you're never coded in your life, give CircuitPython a try. And if you are a software person like I was and want to try hardware, this is great for you as well. Thank you.
All right. Last talk of the evening. We have a first-timer, actually. Sean Harrington on hacking on 23andMe.
Hi, guys. So I actually work for the Patriots. I'm the director of engineering there. So I do nothing pertaining to this in my day job. This is a complete 180 for me. So what we're talking about is basically taking 23andMe's raw data output, which anyone who's taken the test can get off of their website. I've taken that, I've taken my own data, and I've taken dbSNP, which is over 1 terabyte of data, basically tying lots of research publications and genome-wide association studies, and pulling that data all together to see if I can figure out, what diseases pertain to my genome. So what's in dbSNP that we care about here? So what a SNP is, a SNP is basically a mutation in your genome. So, I might have an A, 5% of the population might have a T. That makes that person unique. The exact definition is given right here, so at least 1% of the population has to have it. So it has to be somewhat common. It can't just be a chance mutation. These GWAS allele frequencies that we care about, these are basically big studies that happen across giant populations, just to see how rare that actual allele is. And then the third piece here is we have the clinical significance. So this is, does that allele pertain to a disease, such as cancer, such as diabetes? Now what do we get from 23andMe? We get this wonderful little file here, 4 columns. This is about 20 megabytes, depending on how big or how accurate their data was. It kind of varies here. So we take this and we take that, terabyte or 2 of data, and we want to deduce some information from it. So this is I guess I'm obligated to show some obfuscated IT pipeline diagram here that nobody probably cares about. So basically what we're doing here in the top left corner is we're taking all that data, we're running it, pull it down an old ancient FTP server into this program here, doing all sorts of funky async multi-processing stuff to make this actually run in less than a day here. And we're gonna, chomp that data down from 2 terabytes down to about 50 gigabytes. So what do we care about, right? We've got all this data now, right? There's kind of 5 types of, five labels that these reference SNPs have, right? So either the reference SNP can either be pathogenic, meaning it lends itself to contributing to a disease like diabetes. It can be likely pathogenic, which is just a lesser probability. It can represent a drug response, like a reaction to methotrexate. It can protect you from a certain disease, which is kind of interesting, or it can be a risk factor. So what I'm going to do here is I've got this API all spun up here, and this is actually running locally on my server here. So what I'm going to do is I've got all this database loaded here, and what we're going to do is we're going to use my 23andMe data here, and we're just going to go ahead and grab that information by hitting a REST API. The output of this thing looks something like this. It's this big, nasty, clunky JSON output here. But what we're going to do is we're going to use this little example here. So here's one that pops out. This is interesting to me. My father was hospitalized about 6 months ago because he had gallstones. To me, there's a citation here. If we follow this link, it takes us to a paper on gallbladder disease. I have this SNP that's found in 5% of the population, which I would have otherwise not known that I had if I hadn't run this. So my goal is to find more things like this. So what's next? I've got a Birds of Feather tomorrow. It's going to be at 4 o'clock in room 19. If anybody wants to come check it out, come teach me something that I don't know, because I don't know much about this stuff. I want to make this a public API service. Hopefully you can open source it. And then somebody has to build something to interface with it. Hopefully we can do something there. So hope to see you guys tomorrow, room 19 at 4 o'clock. The slides are available on my website, laziestprogrammer.com. You can get me on Twitter at SeanHare11, and here's my email too, if you want to reach me there. Thank you so much, guys.
Thanks, Sean. Nicely done. Let's give another hand to all the lightning speakers. If you're inspired to give a lightning talk, we have another round tomorrow morning, tomorrow night, and Sunday morning. And so yeah, I'll see you tomorrow morning. Thank you so much.